So, I welcome to the third semester classes, particularly to the subject Mechanics of Materials, which is a course in your VTU syllabus for third semester, and your scheme comes under CBCS and OBE. So, myself, Raviraj, I am in the Department of Mechanical Engineering, Government Engineering College, Chamarajanagar. So, in the first session, we look at the module 1, which is titled as Stress and Strain. So, many of you are familiar with this word stress and strain with the life in your daily life. So, usually we say that we are stressed or strained whenever we work a lot of whenever you do a lot of activities or we work for a long time. So this stress and strain will be there throughout your life, and this concept also applies to the materials. So with this, the subject itself, as we have seen from last few years, it causes a lot of stress and strain to the students. It's a concept, it's a myth that students take it as the subject as a lot of stress and strain to them. But actually, the subject is very easy because it is analytical subject. So based on your analytical skills, the subject becomes easy for you. And also once you go through this session, I hope you can handle the stress and strain caused by this subject. You can overcome the stress and strain once you understand the concepts of this subject, this particular stress and strain concepts. And this subject, this course in VTU, it comes in third semester. The code is 18ME32. So we'll start with session 1, and it comes under module 1. So we have 5 modules in your syllabus, and the first module is stress and strain. So in this session, before we start the actual syllabus, let us look at the syllabus as per your as mentioned by VTU. So here the subject is called as the course. So we call this as course here. The subject is called as course. And you have 4 credits for this with the internal marks, that's continuous internal marks of 40 marks, and semester end exam 60 marks. So we have some outcomes, what is called as learning objectives for this subject or for this course. So the objectives are based on the different modules where the syllabus is designed. So different modules from each module we will be learning some objectives or some aims of this particular learning of the particular modules. So in the first module, as I told you, that we learn about the concept of stress and strains. So in this module, a lot of new concepts will be involved, like what is called as properties of materials. Then you should define stress and strain. We should look at some theorems, Hooke's law, and we should learn how to draw a structure diagram for different materials. And also there are some numerical problems based on these equations, what to derive, or the theorems, what to learn in this chapter. And also we look at how the temperature causes stresses, and we look at the different strain, shear stress, strain, and also we look at different elastic properties of the materials and try to establish relationship between them. So based on this module, the content, we have the learning objectives. For example, in module 1, you learn stress and strain. So we have learning objective of this module will be to know the different types of stresses and strains developed in the material, which is subjected to different kinds of loading: axial, bending, shear, torsion, and thermal loadings. So as you go further, when you go in deep inside the modules, you can understand all these terms. So before we go into the subject, into the module. Let us see the syllabus. So this is the first module. Similarly, you have the second module here, wherein you will be learning about stress and strain, analysis of the stress and strain. So once you understand the concept of stress and strain, you will try to analyze how to calculate or how to find out the stress and strain when the metal is subjected to different kinds of loading. And also we have in the second module we will learn about cylinders, and the cylinders are classified as thin and thick cylinders, and we have some concepts, some theorems which are applied to the cylinders. And in the third module we will understand some kind of what is called a shear force, and the bending moment caused by this shear force on the particular structural members called as beams. And also we will study about the stresses in beams. So in beams they are subjected to bending and shear. So we look at beams with the different cross sections. And in the fourth module we look at theories of failure. So in this theory, in this module or in this concept, so in the previous concepts you will learn about how the material behaves, and in this module you will understand or you will come to know about the theories proposed by different engineers and mathematicians, which proposes how the material fail. So some theories are there in that. Only two important theories will be there in your syllabus. And coming to one more chapter in module 4, it is a torsion. So torsion is nothing but twisting moment, or the phenomena of twisting moment, or a phenomena of rotating shafts, and what are the stresses induced when the shaft is rotating. So that concept is called as torsion. And in module 5 we look at columns. So just like beams in structural members, beams, similarly we have columns in structures, particularly civil structures, your buildings and all those things. You can see the columns, and we look at how to analyze the columns with the different theorems. And in the end we look at the strain energy. So how the energy is stored in the material with the different kinds of loading. So this is about your syllabus of this course, and we will look at so here again at the end of the course, at the end of the learning of this particular subject, we have what is called as course outcomes. So it means that what is the outcome of learning of this course from the students, what you can expect. So each module they are given one outcome. So in the first module, after learning the first module or after understanding the first module, the student should be able to understand what are the different stresses and strains and establish relations between them. Similarly, when you look at module number 5, the outcome of this module should be the student should be able to analyze or to solve some problems based on columns for stability. So like that, each module will have the course outcome. So if you look at all the modules, it becomes a course. So if you consider all the modules, what is the outcome? What student has learnt? That is given here. So at the end of each module, you should be able to do these activities. So anyway, this is a question paper pattern. All of you know this. And before that, we have some textbooks. So mechanics of materials, many books are there. So before few years on the last previous schemes, the subject was called as strength of materials initially, and as the syllabus was particularly, this subject was for both the mechanical and civil engineering, strength of materials, and particularly this name was changed as mechanics of materials for mechanical students. So anyway, it's a same name, content is same, strength of materials, or you can refer mechanics of materials book. So many books are there which are referred or which are suggested by your VTU. So you can refer any of these books. So here, coming to the introduction. you can see that mechanics comes under what is called as your science or physics. So the physics you are learning from your maybe from high school teaching itself, and in physics you learnt about a lot of forces and how to resolve the forces with some applications. So this physics itself is a vast subject, and we have different branches of this physics, and particularly mechanics is one such branch of physics wherein you will be studying about what happens to the materials when the load or force is applied on them. So mechanics is basically the input or the external force or external property which is being applied on the materials. So here the external factor which is affecting the metal is the force or the mechanical load on the materials. So we call it as mechanics here. Similarly, when the input is thermal, when the input to the material is heat or temperature, we call this as thermodynamics. So the subject is also there in your third semester course, third semester syllabus. So one subject is there, one course is there on thermodynamics also. So similarly, if we take electricity is also a part of physics, wherein we learn about charges in the material. So in this subject, we'll ignore these two other properties of physics, whereas we'll concentrate only on mechanics here. So mechanics is basically we'll try to understand what will happen to the materials when load or the force is applied on these materials. And you know, materials are designed and manufactured to give a particular shape, and it becomes a mechanical component, and that component is used for different engineering applications. And in mechanics, as you know, again we have, depending on how the forces are acting on the object, so we have statics and dynamics. So mechanics is again divided or classified into statics and dynamics. And again, dynamics, we consider the forces causing the motion of the object, we study under kinetics. And if we don't consider the forces which cause the motion of the object, it is called as kinematics. Statics is nothing but the objects are in equilibrium. So that is what the forces, the action of forces, or the how the material behaves to the external forces or loads on the materials which are static or which are not in motion or which are in equilibrium condition, that is called as statics here. So here again mechanics, as I told you, it depends on particularly the materials. So the materials we simply call them as bodies here. So bodies or materials, what we see around us, some are rigid bodies and some are deformable bodies. So rigid body means they are not flexible. That means the materials will not get strained when you apply the load, or the materials will not, in simple words, the materials will not change their shape when the load is applied. So that kind of objects or materials or bodies are called as rigid bodies. And there are some materials, so on which when you apply the load or force, they change their shape. So when the material changes the shape, that concept is called as deformation. So usually the bodies or materials around us, we can classify them as rigid bodies and deformable bodies. So in this syllabus, or usually mechanics, we use because most of the materials are deformable. We classify them under, we take them under this mechanics of deformable bodies. We study them under mechanics of deformable bodies. And again, in deformable objects or materials, you know that materials can be matter, as such. In general, matter can be, or metal can be classified as solid, liquid and gases. So in deformable bodies, we again divide the objects or materials or matter into two things here, So one is the solid body, or one which is so solid. All of you know that the arrangement of atoms. Again, how the metals are classified based on arrangement of atoms. So in solids, the arrangement of atoms, you know, they are very closely packed, and again we have some properties for solid materials. So those on those materials we apply the mechanics, and that concept is called as solid mechanics. And coming to liquids and gases, you know, fluid is a word which is used to characterize liquids and gases together. So they are generally liquids and gases together. They are generally called as fluid here. So one more concept of mechanics is you can apply the mechanics to the fluids. So fluid is nothing but it's a mixture of liquid or gas, or maybe liquid or only gas. So for example, water is a liquid, air is a gas. So we can simply call them as fluids. So water is one fluid, so air is also a fluid, like that. So fluid is nothing but it can be a liquid or a gas, or it can be combination of liquid and gas. So that material, that fluid, how the behavior of those fluids when the load is applied, that comes under fluid mechanics. So the subject is again, this course is there again in your higher semesters of mechanical engineering. So in this semester we will concentrate only on solid mechanics. So we will see what happens to the solids, or what happens to the solid materials when the load is applied or when the force is applied. So mechanics is only, we will see the external factor is the load or force. So what happens to the solid materials when the load or force is applied, that we will study in mechanics of materials. Actually the subject name should be, instead of mechanics of materials, it should have been solid mechanics only, because in the next semester we have one more subject, fluid mechanics. So this subject could have been called as solid mechanics instead of mechanics of materials, particularly in this semester. Anyway, so all this other classification we will see later. Let's not worry about this in this early stage for you people. So we will see the solid mechanics, or what is called as mechanics of materials, as per your subject, as per your course. So we can call this mechanics of materials as solid mechanics. So your subject is, or the course what you are learning now will be, you can call it as solid mechanics also, instead of simply mechanics of materials. So mechanics, as you know, I told you that the forces or load which is being applied on the different materials or different bodies, and when the load is applied or when the force is applied on the bodies, the materials react to them, just like human beings. So here we are also some kind of materials. So whenever some external factor is applied on us, we react to that external force or external load. Similarly, the materials, when you apply the load on them or force on them, they react in some particular way. So different materials behave, or different materials react to the forces in different way. So that study, so how the materials react to the different forces or load applied on them, that is called as mechanics here. So also we saw that mechanics, we have two parts. We can study the mechanics in two parts, statics and dynamics. So in this syllabus or in this course, we are learning only the statics part of the mechanics. Dynamics we are not learning in this course here. So again, we have different course in your higher semester about kinematics and kinetics. So we will be studying only the statics part of your subject, mechanics of materials or solid mechanics. So in statics, the bodies or the materials are in equilibrium, and we study, or we try to understand what happens to the materials when the material is in equilibrium, and how the materials react, or what are the reactions of the material to the loads or forces applied on them. So before actually we enter into mechanics, so let us know different materials available for us. So in engineering, we use the basic part of any component or any system is the material. So a lot of materials are used, as you can see around yourself. in our daily life we use a lot of materials, starting from metals, wood, then plastics, okay, paper, organic materials, many ceramics, like that. So glasses are there, tiles are there, okay, wood is there. So we see a lot of materials around us, and we have been using these materials since the evolution of human beings. So in engineering also we use these materials because the materials have different properties, different characteristics, and depending on each material characteristics, the metals are applied to different applications in engineering. So you can see some materials, for example silicon, germanium and all, they are used in electronic components, whereas mild steel, cast iron, all those things, they are used in mechanical components. Similarly, for electrical components we have electrical materials which have electrical properties. So all the metals and alloys, or ceramics, they are used in electrical applications because of their electrical properties. So similarly, all metals, they have different properties, mechanical properties, electrical properties, something like that. So here, before we go into the mechanics, understanding how the metals behave, let us see what metals are available for us. So this concept of materials, again there is one course in your third semester, material science. So in material science also all this is covered. So but in this course, before we start the actual mechanics, understanding mechanics, let us see some general materials available for us. So generally engineering materials are classified into four parts, four components. So first one comes as metals and alloys. So where, for example, you have mild steel or steel, simply steel, all of you are familiar with steel. So steel is an alloy of iron and carbon. So iron is a pure metal. So like that we have copper, we have aluminium, we have silver, gold, like that. So cobalt or magnesium. So they are all metals in pure form, elements in pure forms, and steel is an alloy. So apart from metals, we have something called as alloys. So alloys are nothing but basically we mix metals with some other material, some other metals or other materials. It becomes an alloy, where the properties of the alloy is greater than the metals. We'll understand all these things in material science in detail later. But here let us just look at metals and alloys here. And one more class of metal is the plastics. So all of you know, many of you, in our daily life we use the plastics. And also one more classification of metals is the ceramics. So ceramics are nothing but, simple example I can give is glass, and your household tiles or walls, ceramic, that RCC, cement, bricks, concrete, granite, stone. So all the stones, they are glasses, they come under ceramics. And we have a new kind of class of materials called as composites. So composites are materials wherein we mix or we combine different materials like metals, plastics, ceramics with different proportions, and where we get the properties which are enhanced, which are greater compared to the base materials like metals, plastics and ceramics. So here in solid mechanics we concentrate or we understand only the mechanics of metals here, or the alloys. So again, metals can be classified as ferrous, non-ferrous, all those things you know. Plastics can be classified as thermosets or thermoplastics or elastomers. And ceramics also, they are basically oxides and nitrides, carbides of different materials, base materials. And composites are again based on, composites is basically made up of two, it's a material in which two types of metals are there. One is called as matrix, other one is called as reinforcements. But anyway, we will see about metals only here. So most of the engineering materials in mechanical engineering, we use a lot of steels. And in steels again we have different numerous number of types of steels. For example, stainless steel, all of you know, which is used in usually kitchens of our houses because of their corrosion resistant properties. And also we used different kinds of steels, tool and die steels, which are used in machining concepts, machining applications. Then we have the alloy called as cast iron. So like this, many of the engineering materials, particularly for mechanical engineering, they are steels and irons. And along with that, we have non-ferrous metals like aluminum, copper, titanium, tungsten, molybdenum, cobalt, something like that. So all these are non-metals, non-ferrous metals, are alloys. So particularly in mechanical engineering, we should understand, or we should know some of the basic metals and alloys here. So steels, aluminum, copper, then titanium, all those things. So basically, again, if you go back to your high school chemistry or physics, we have elemental table. So basically, all the metals, what you just now you saw, all the metals, they are basically elements in the periodic table, and which are available in the Earth's crust as some mixtures. So we have iron based metal, or non-ferrous is nothing but in which there is no iron. General classification of metal is ferrous and non-ferrous. So many of the materials, they have some iron content, so they are called as ferrous materials, and remaining materials which do not contain iron, they are called as non-ferrous materials. And alloy, I told you that metals is a pure forms of elements present in the nature. Metals like you have all these are metals. Ferrous, we have iron, then we have chromium, cobalt, nickel. So all these are basically metals, which are the elements in the periodic table. So if for these metals you add some other materials, you combine with other materials, it is called as alloy. For example, steel. Now, steel is an alloy of iron, that is Fe, and carbon. So if you combine iron and carbon, it becomes a steel. So like that, many alloys are made by casting different combination of metals and other materials, and we get an alloy. So here we can see some examples of alloys. So basically, alloy will be having some base metal like copper, aluminum, tin or iron, and to these base metals we add some other materials, some other metals or non-metals. For example, when I add zinc to copper, it becomes an alloy called as brass. So the example of brass, all of you know, they are used in, you can see the figures from the photo, you can see some applications. For example, this is a musical instrument. This is also a musical instrument. We have the clock. Then we have some medals here. So all of you know bronze medal. So that is also an alloy. So like that, we have door handles or door fixtures. They are basically brass. Similarly, we have one more alloy of copper called as bronze. So all of you are familiar with bronze medal. So bronze is again a mixture of copper and tin, and they are basically used in making statues. You can see the bells, door fittings, and other materials, coins, like that. Similarly, one more alloy, basically all of you might have known in soldering electronic components or to join wires, we use a soldering process, and that material alloy is called a solder. So solder is a mixture of lead and tin. It's a soft alloy. It can easily bend it. Similarly, we told about stainless steel. So steel is basically iron and carbon, and if you add chromium and nickel along with iron and carbon, it becomes a stainless steel, which is having different properties, different characteristics. Based on that, name is given as stainless steel, and it is basically used in kitchens and cutlery things because it is having very high corrosion resistance. Like that, many engineering materials are available, and one more important thing you have to understand for materials is their properties. So properties are nothing but we can simply call it as characteristics of the material. For example, if you take human beings, we also have different characteristics. So each individual or each person have their own characteristics, maybe inherent or acquired. So that characteristics or that behavior is called as properties. So all the materials, they have different properties. That means they react different in a different way to the external load or force applied. So depending on the external factors applied on the materials, we have different material properties. For example, when you apply the load or force on the material, and if you study the behavior of the material, that load or force, or how the material behaves to the load or force, that property is called as mechanical property. So mechanical properties is nothing but how the material behaves to the external force or the load applied on that material. Similarly, we have thermal properties. Thermal properties means you take the same material or any material and you apply temperature or heat to that, and you observe how it behaves or how it reacts. So that is called as thermal properties. Similarly, optical properties are there. So optical means related to light. Okay. So when you apply the light on the material and how the material behaves, what characteristics it shows or how it reacts to the light, that is called as optical properties. Similarly, we have electrical properties. So electrical, as you know, it's nothing but voltage and amperes, how the charges are transferred, conducted in the material, electrons move in the material. So similarly, when you apply the charges or how the electrons move, when you apply the voltage, how the electrons move inside the material and how the material reacts to this electrical input, that properties are called as electrical properties. Similarly, we have chemical properties, magnetic properties. So all of you know these magnets. We have physical properties like shining or the surface texture. So all those come under physical properties. So here we are studying the important thing in mechanics of materials or in solid mechanics. We look at only the mechanical properties of the engineering materials like steel or copper alloys or aluminum alloys. So mechanics is basically it is nothing but studying about the mechanical properties of the materials. And mechanical properties means, I told you that when you apply load or force on the material, how the material behaves. So that behavior study, it is called as mechanical properties or mechanical behavior of the materials. So mechanical properties, as you know that from those mechanical properties we can measure or we can understand how materials behave when load or force is applied. And also mechanical properties, they help us to understand the relationship between the response, that is how the material react to the load or forces, and also how the material deforms, change the shapes when the load is applied on them. So we told about mechanical properties. So properties of materials that makes us know how the material behave under applied forces. Those properties are called as mechanical properties. The mechanical or mechanics, basically it is the applied forces, external applied forces on the material, and how the material react or behave to the external applied force, that comes under mechanical properties. So again, mechanical properties, we have a lot of mechanical properties you can see here. So you can see how the material reacts to the force or load. So the material reacts in different ways to the load or forces. So depending on each behavior, we have each mechanical properties here. So first one is the strength. So all of you know about the strength. We use the word strength in our daily life for different under different conditions. So strength is basically how the material reacts to the force, or how much capacity the material has to hold that force or to react to that force or the load there. So like that, there are many properties like elasticity. So elasticity is nothing but, in simple words, when you apply the load or force on the material shape changes. Shape means the length or maybe diameter. The shape will be changing, and once you remove the load or force on the material, it comes back to the same position or same shape and size. In simple words, that is called as elasticity. Similarly, stiffness is nothing but, again, is how stiff the material is. It's basically how stiff the material is to the applied force. So how much how much elasticity it is having, how much it can resist the what is called as yielding of the material, or what is called as plastic deformation of the material, that is called as stiffness. So like that, we have flexibility, plasticity. So elasticity and plasticity are the two forms of deformation. So initially the metal deforms elastically, and then when the metal deforms permanently, when the shape of the metal changes permanently, it is called as plasticity. So like that, you might have studied ductility, malleability, then hardness, then we have toughness, then we have creep, resilience, then fatigue is there, machinability is there. So all these are the behavior of the material when the external load is applied, and the load can be applied in different ways. So depending on how the load is applied, what is the magnitude and direction of the load, and also for how much time the load is applied, the metal behaves in different ways, and based on each behavior we have these properties. So like that, just remember that in basically mechanics of materials, in this course we will basically study strength. Stress and strain is nothing but it comes in strength of the material. That's why the subject is also called as strength of the material. And remaining other materials also we will be understanding a little bit here, but more of the learning in this subject is based on strength or stress and strain of the material. And machinability, fatigue, all those things you will be learning in next higher semester subjects, in design and in machining processes, something like that. So all these properties you will be learning in different courses of mechanical engineering, and the strength basically you will be learning in this course, stress and strain, particularly in this strength of materials or mechanics of materials course. So coming to strength, in simple words, we can say that it is the capacity of the material to resist or to withstand the load, applied load, without failing or destruction. That is called as, in general word, is called as strength. And also the word stress is used. Stress is also the contemporary word for this strength. So we'll define stress and strain later. So stress is when you apply the load on that material over the area, it becomes a stress, and when you apply the more and more load, it cannot hold. That means the capacity of the material, when the load increases more than the capacity of the material, it will fail. So that is nothing but when the load increases more than the strength of the material collapses or fractures. So basically remember that strength is nothing but how much or what is the capacity of the material to take that load, applied load. And similarly, elasticity, I told you that in simple words, when you apply the load on the material, the material deforms or it changes the shape, and when you remove the load, again it comes back to the original shape and size. That is called as elasticity. And stiffness is again I told you, it is related to elastic deformation and how much resistance the material offers to the elastic deformation. That is called as the stiffness. So stiffness is, again you can say, it is how much rigid the metal is to the applied load. So it is particularly applied to the elastic deformation. So stiffness is applied to the elastic deformation, is a measure of elastic deformation, whereas toughness is a measure of plastic deformation. So I told you there are two. Deformation means change in shape and size. So initially the metal will have elastic deformation, and how much elastic deformation metal undergoes, or how much uh, resistance the metal offers to the elastic deformation or elasticity, that is called as stiffness. And toughness is nothing but the how much energy the metal absorbs, or how much force is needed to for the material to undergo plastic deformation, that is measured in as toughness here. So all these concepts you will be learning in different courses in higher semesters. Similarly, stiffness, okay, just now we discussed about that. So that the resistance, how much the material will resist to the elastic deformation, that is called as stiffness. So deformation is nothing but change in shape and size. Similarly, deflection is also change in shape and size. So all these words we should remember: deformation, deflection, stiffness, all those things. And in stiffness we have one property, just like Hooke's law, and we will be studying about this in detail later. Similarly, we have flexibility. So as the name indicates, flexibility is nothing but how the metal can bend easily or deform easily, in general words. So I told about plasticity. So plasticity is nothing but permanent deformation of the material. So permanent change in shape and size, that is called as plasticity. So different metals like steel, aluminum, copper, they have different plasticity compared to some metals called as plastics. So the name class of metal is there, plastics only. So where the plasticity is more compared to metals and alloys. And again, ductility is it's a property of the material by which the metal undergoes high amount of plastic deformation, and particularly it is used to, that process or this property is used in making wires of metals. For example, copper wire is we can convert, or we can convert the copper material or what is called as a piece of copper into thin wires by its property called as ductility, where ductility is nothing but when you apply the force in a particular direction, the material or the metal will elongate. It will elongate plastically, permanently, without fracturing. That is called as ductility. So ductility is the property, and that property is used in making wires of metals. Similarly, you have heard about malleability. So malleability is also it's a ductile property, or where the metal will undergo deformation, plastic deformation, and in malleability we convert a block of material into thin sheets by applying forces at different directions. For example, hammering. So hammering is nothing but you are applying force at different points on the material. So when you apply force on the different points on the material in all directions, in all parts of the material, it will elongate, or that it will deform plastically in all the directions, and we get thin sheets. So we might have used aluminum sheets, then copper sheets are used, steel sheets are used. So that property which makes the metals or alloys to convert them into sheets by applying forces, that property is called as malleability. So we have toughness here. I told you toughness is the ability of the material to withstand plastic deformation. So toughness is actually, we can measure how much energy, or how much energy is absorbed by the material before it fractures. So by knowing the amount of plastic deformation, we can measure how much plastic deformation has occurred. That is called as toughness. The toughness is again that property is used in vibration and shock absorption of the material. And we have one more property like resilience. So you know that in physics you have learned it's the ability of the material to absorb energy in the elastic deformation. So for example springs, the term resilience is used, and we have proof resilience. So the maximum energy that the material can absorb in the elastic deformation, that is called as proof resilience. And we have modulus of resilience, nothing but it's a ratio of proof resilience over the volume of that material. So these are some of the terms which are related to the properties. So resilience is how much energy is absorbed by the material. So when you apply the force or load, that is nothing but energy itself. So how much load or force it can absorb, that is called as resilience. And one more term is hardness. So it's an important mechanical property of the material. So hardness is all of you will knowing that you will be using this word in your daily life. So it's nothing but how hard the material is. That means how much resistance or the ability of the material to resist what is called as scratching, cutting, or abrasion, indentation, or penetration. That is called as hardness. And it is related to the strength again. If the strength is more, hardness will be more. So we have some tests to find out how much hard the material is. So we can measure the hardness in terms of numbers. So for that we have different machines or different testing. For example, Vickers hardness, Rockwell hardness, all those things. So depending on that, even melting point of the metals also is related to the hardness of the material. And we have brittleness. So brittleness is nothing but, for example, you take aluminium. For example, we just now we talked about elasticity, or what is called as malleability and ductility. So malleability and ductility are where the property where the material will undergo a large amount of plastic deformation. The opposite of ductility is brittleness. So brittleness is nothing but the property of the material wherein the metal will break easily or fracture easily, or it will break into pieces easily. For example, I can say glass. Simple example is glass. So you take a glass and you just apply sudden force or load on the glass. For example, you take a stone and hit on the glass, it will fracture easily. That is called as brittleness. But if you take a sheet of metal like aluminum or steel sheet, and you take a stone and hit on it, it will not break, it will not fracture into pieces, but it will undergo plastic deformation, what is called as dent. We call it as dent. So like that, the opposite of ductility is brittleness. So ductility is nothing but when you apply load, it will absorb the energy and it will undergo plastic deformation. Whereas brittleness is nothing but that property of the material wherein the metal cannot absorb the load or force or energy, and it fractures very easily. It cannot take more and more load, and it fractures very easily. So cast iron is again one such alloy which is a brittle material or which exhibits brittleness. So machinability again, so you know many of the mechanical components or engineering components are given some shape and size. So when you want to give the shape and size to the material, machinability is one such process by which you can give shape and size to the material. So how much the material allows us to change the shape and size of the material by using machines or cutting tool, that is called as machinability. So all these things you will be studying in other courses in detail later. So just remember the machinability here. Similarly, we have creep. So creep is again a slow deformation of the material when subjected to constant load over time. So that is one phenomena. Creep is one phenomena where the metal deforms plastically. Similarly, we have fatigue property. The fatigue is nothing but here the load applied will be varying, fluctuating, and it is repeated. So the metal is subjected to repeated and fluctuating loading, and this causes the metal to fail. That phenomena is called as fatigue loading. The fatigue loading is nothing but the load which is applied continuously, and which is varying. The amount of the quantity of the load is varying there. For example, you take a shaft, that is a shaft which is rotating, so that undergoes fatigue. And even in your IC engine, the piston, you have the connecting rod, then you have crankshafts, which are subjected to fluctuating loading under different speeds of the vehicle, so that causes the material to fail. That phenomena is called as fatigue. So fatigue means the load will be varying, it will be fluctuating. The amount of load what we are applying, that will be fluctuating or varying. So the same thing, just now we discussed the different properties of the material, and that definition is given in the form of tabulation here. So in simple words, we can understand the different properties of the materials. So basically remember different properties of the materials like strength, elasticity, plasticity. Then you have the stiffness, that is the Young's modulus. We will see that later in detail. Ductility is there, malleability is there. Ductility and malleability are related to plastic deformation of the material, related to plasticity. Whereas you take brittleness, it is related to the elastic deformation, or where the plastic deformation is not much in the materials. And toughness is again, it is both related to measure of both elastic and plastic deformation. So how much energy or how much the material capacity is there to withstand the loads under elastic and plastic deformation. And similarly, we have hardness. So hardness is the ability of the material to resist, I told you, scratching. So if it is very difficult to scratch on a material, then the hardness is more. And also cutting is not easy for higher hardness material. Similarly, indentation, we cannot make any indent in the material when the hardness is more, like that. So creep and fatigue, they are phenomena where the loads are varying with respect to time for creep, and here the load is varying with respect to its magnitude, and it is continuous. So these are some of the behavior of the material to different kinds of loading or forces. So that's it for this session, and in the next session we will continue the remaining concepts. Thank you.